In this video, we're going to discuss about this Tier 1 GAPC 4.0 Criteria 7 and 8. Criteria 7, that is Facilities and Technical Support, carries 100 mark. Criteria 8, Continuous Improvement, carries 80 mark. So this we're going to discuss about in detail about in this video. So the Criteria 7, Facilities and Technical Support, carries 100 mark. So the out of 100 marks can be classified into 5 categories. The 7.1, that is adequate and well-equipped laboratories and technical manpower, consists of 40 mark. Additional facilities created for improving the quality of learning experience in laboratories carries 20 mark. 7.3, maintenance of laboratory and overall ambience 10 mark. Safety measures in laboratory 10 mark. 7.5, project laboratory, research laboratory, center of excellence 20 mark. So in 7.1, adequate and well-equipped laboratory and technical manpower, that is carries 40 mark. So in the new SAR GAPC 4.0, that is table number 7.1.1, list of laboratory and technical manpower. The list is provided below. There is serial number, name of the laboratories, number of students per batch size, name of the major equipments, weekly utilization status of all the courses for which the lab is utilized, technical manpower support, name of the technical staff, designation, and their qualification. So this is about evaluation guideline for 7.1. There is adequate and well-equipped laboratory and workshop to run the program is 15 mark. Quality of instrument, there is 5 mark. Utilization 10 mark. Availability of adequate and qualified technical support staff carries 10 mark. The documents evidence are required. There is a list of laboratory and workshop with the name mapped to curriculum requirements, followed by area of each laboratory workshop, that is in terms of square meter with the compliance to AICTE norms. And the third one, the list of major equipments with the cost, year of purchase and working condition. Fourth one, equipment versus syllabus mapping to provide curriculum requirements are made, followed by stock register, consumable and non-consumables, followed by annual maintenance contract or repair logs of lab equipments. So next one, there is list of technical manpower, lab technicians, workshop instructors, attendance with qualification, experience and role. Next one, there is students equipment ratio during the lab session. Last one, lab utilization schedule, that is timetable shows adequate usage. So let us take one case example, CAD/CAM laboratory. Suppose of the class having student strength as 60, the total availability of the system in the CAD/CAM laboratory is 30, then we have to divide the total class strength into 2 batches, that is each batch consists of 30 students. So that one student is equal to, there is one system, there is 1:1 ratio that we have to follow it. So this is the batch size of laboratory. So the laboratory utilized for, we have CAD lab, second one CAD CAM lab, third one project work. So the strong evidence of the laboratory utilized is, that is student strength, batch division, laboratory timetable, 30 batch size, then 30 working systems, course utilization, students practical works, that is hands-on learning, and assessment pattern and learning outcomes. So this is how we have to provide the strong evidence for the criteria 7.1. We should not claim that we have the CAD laboratory with 30 systems. So that is about one of the weak evidence. 7.2, that is additional facility created for improving the quality of learning experience in laboratories, that is carries 20 mark. So the table number 7.2.1, the list of additional facilities, that is we have to list all the additional facilities having in that particular program. Name of the facilities, detail, purpose of creating the facilities, utilization, relevance to PO and PSO of that particular program. So evaluation guidelines, there is availability and Relevance of additional facilities carries 10 mark. Utilization and effectiveness of facilities carries 5 mark. Relevance to PO and PSO mapping carries 5 mark. So total put together it is about 20 mark. The document evidence required we will discuss one by one. There is a list of new or additional facilities created beyond the curriculum norms, followed by purchase order, bills, stock register of newly procured equipment software, record of upgradation, modernization, that is example advanced tooling, CNC machines, 3D printer, simulation software, IoT kits. Utilization record, timetable shows the use of additional facilities. Students project report, mini project using additional facilities, MOU, industry collaboration record for lab upgradation, funding documents, that is TechCube, AICT, ModRops, institutional budget, and etc. Next one, there is photos, videos of additional facilities in use. Last one, lab manuals updated to include value addition experiment using new facilities. Case example, facilities created versus facility used. For example, we have the 3D printer facilities. Now we have to show the evidence, that is facility created value and improved learning. The need identified is students had difficult to convert CAD model into a physical prototype model, followed by the facilities as created, that is 3D printing facilities established in the year of 2025, used in CAD/CAM and project courses. 45 students have benefited to fabricate the prototype by using the 3D printing facilities. The students demonstrate design to prototype capability, that is learning impact, and we have to map the relevant PO and PSO, that is engineering practice and problem solving outcomes. Evidence to maintain, that is facility proposal or need analysis, proposal, purchase and installation document, photography, utilization record, course utilization, training conducted, students project using facilities, PO, PSO relevance, feedback, and impact analysis we have to carry out for that particular equipment. One of the weak approaches, so we have 3D printing which was purchased in the year 2025. It shows only the purchase evidence, not the utilized or impact. We should avoid the weak approaches. Additional facilities, there is evidence of impact. Suppose if you have the 3D printer, the number of students or model or prototype has been developed. Likewise, we have to provide there is evidence of the impact. The CNC training unit, the number of students have trained. Similarly for EV training kit, the course or project utilized in it. Next, additional facilities, answers workstation. There is simulation project has been carried out. This kind of paper has been published in well-reputed journals or Scopus indexed journals. Likewise, we have to climb. So that is one of the evidence of the impact. Similarly, for IoT equipment, that is mini project has been carried out by using this particular facilities. 7.3, that is maintenance of laboratory and overall ambience carries 10 mark. The evaluation guidelines, maintenance policy consists of 2 mark. Corrective and preventive maintenance carries 3 mark. Overall ambience carries 5 mark. Evidence required for maintenance of laboratory and overall ambience, that is laboratory maintenance logbook, that is cleanness and service schedule, annual maintenance contract, and a repair record of major equipments, calibration certificate of the precision instrument, lab inspection report, budget allocation and utilization record, lab utilization register, timetable, safety compliance record, housekeeping schedules, laboratory ambience monitoring reports. Last one, feedback form from the student or faculty on the lab environment. 7.4, safety measures in laboratory carries 10 mark. Based on the evaluation guideline, there is basic safety measures carries 4 mark. Lab specific safety measures that carries 6 mark. So what not to do in the lab: wearing saddles, forget gloves, forget goggles, loose hairs, eating in the lab. So these are the instructions that has to be provided in the every laboratory. Lab safety reminders in clinical laboratories, one of the example: attention and behavior, food and drink restriction, personal protective equipments, equipment handling, sample and container labeling, workspace hygienic, waste disposable. So these are the some of the there is personal protective equipments. So every student must be aware before operating any kind of equipments or handling any kind of chemical hazards. So they have to wear proper protective equipments. So some of the evidence that have been taken from the website, thanks to sciencenote.org. Safety measures in laboratory, the document evidence, laboratory safety policy and rules of handbook, signed students undertaking and declaration form, laboratory manuals of all the courses, photographic evidence, record of safety orientation and training program should be given to the student. This for personal protective equipment register, electrical safety certification and logs, chemical management records, equipment and machinery safety records, first aid management record, fire safety records, fume hood and ventilation certificates. Another, there is safety measures in the laboratory. There is lab safety organizational chart, minutes of safety committee meeting. There is a regularly minutes from the department or institution safety committee meeting where the lab safety issues are discussed, reviewed, or action items are assigned. Internal safety audit report, action taken report, accident or incidental report, the formal logbook to record any safety related incident, near misses or accidents. It should include date and time, description, person involved, corrective action taken. Policies of procurement of safe equipment chemicals. 7.5 project laboratory, research laboratory and center of excellence. So the evaluation guideline, availability of project laboratory or research laboratories carries 5 mark, availability of center of excellence 5 mark, utilization of project laboratory or research laboratory center of excellence carries 5 mark, relevance to PO and PSO mapping carries 5 mark. So the table number 7.5.1, the list of project laboratory or research laboratory or center of excellence, we have to list the name of the laboratories in that particular program. As per the evaluation guideline, the availability of the project laboratory and research laboratory, the documents are lab inventory infrastructure list, equipment inventory with specification, photographic and virtual evidence, lab access and booking policies, annual maintenance contract and calibration certificate, lab in charges profile. In 7.5b, there is availability of center of excellence. There is CO, charter or MOU, center of excellence brochure or profile document, list of specialization, equipment, software, evidence of joint funding, governance structure. So these are the documents that should be required for the center of excellence. 7.5.c, utilization of project laboratory, research laboratory, center of excellence. So some of the documents that we have to provide, there is lab utilization, booking record, final year project list, list of students publication and conference paper, record of prototype, product developed, record of training, workshop conducted, consultancy and testing report, usage of statistical summary. We have to map the relevance to the PO and PSOs, the sum of the document evidence. There is mapping of lab or CO to PO and PSOs, project proposal with PO and PSO mapping, courses, project lab manuals, direct assessment evidence, students' portfolio, samples. So these are the documents that we have to maintain in the criteria. 7.5. One of the case example for relevance of PO and PSO mapping. So here I am considering there is PO1 to PO5 and PSO1 and PSO2. So let us take example, there is lab 1, engineering practice or manufacturing lab. Mapping, there is PO1, PO2 and PO3 carries 3 weightage, there is strongly correlate. PO4 moderate, there is 2. PO5 moderate, there is 2. Similarly, there is PSO1 represent, there is strong correlation, that we have to map it as number 3, and PSO2 there is moderate, then we can mark it as 2. Similarly, for strength of material laboratory, thermal engineering laboratory, CAD/CAM manufacturing laboratory, mechatronics and automation laboratory, the PO and PSO mapping. It is a case example. Next, we are going to discuss about criteria 8. There is continuous improvement, carries 80 mark. There are 4 sub-classification criteria 8. There is 8.1, action taken based on the result of evaluation of COs, POs and PSOs, carries 40 mark. The 8.1 itself having 2 classification, that is 8.1.1, action taken based on the result of evaluation of CO attainment. 8.1.2, action taken based on the result of evaluation of PO, PSO's attainment. Each carries 20 marks. 8.2, academic audit and action taken thereof during the period of assessment, carries 15 mark. 8.3, improvement in faculty qualification and contribution, 15 mark. 8.4, improvement in academic performance, 10 mark. So 8.1, the action taken based on the result of evaluation of CO, POs and PSOs. So let us take one of the case example. CO target for that particular course is 70 for all the 5 COs. For each CO, the attainment value is CO1, that is 74. Similarly for CO2, 61, 64 for CO3, and CO4, 58, and CO5, 67. As per the target, only the CO1 is attained. The rest of the remaining 4 is not yet attained. So we have to identify the gap, and according to the gap, we have to what kind of implementation that we're going to follow in the subsequent semester. So for example, analysis of stress and failure, the target value is 70, but the attainment value is 61. The difficulty in applying the failure theories. So we have to implement the additional number of tutorial class or concept map to attain the particular CO target. So likewise, we have to implement the action to improve that particular CO target. Identified weakness, the major gaps identification from CAY M1, that is CO analysis, application of failures in numerical problem, systematic machine elements design procedure, shaft and gear design calculation, limited use of engineering software, difficulty converting theoretical concept into practical design discussion. As per the evaluation guideline, the documentary evidence of identification of the gap in CO's attainment is 5. Plan of action to bridge the gap or improvement carries 5 mark. The implementation part carries 10 mark. So what are the action plan implemented to improve that particular CO? So the curriculum intervention, that is adding application oriented numerical problem to tutorials. Introduce additional design case studies beyond routine textbook problems. Incorporating industrial oriented machine component examples. Pedagogical initiatives, worked examples, guided problem, independent problem approaches. Case-based learning for shaft, gear and bearing design. Peer learning problem solving session. Short concept recap session before numerical problems. Support system improvement. Additional tutorial class, remedial session for slow learners. Topic-wise question bank with graded difficulty. Individual feedback on design calculation. Additional practice through LMS or digital learning resources. Technology integration, SolidWorks demonstration for machine elements modeling, ANSYS demonstration for stress displacement interpretation. Students asked to compare analytical calculation versus simulation result. These are the some of the action plan implemented document. So this is how we have to implement the process. Let us take one of the case example, that is mission design for third year BE mechanical engineering. So if the CO was not attained, that we have to identify the gap. For the identification of the gap, we have to take the action plan. For that action plan, we have to implementation. Then we have to reassess and improvement to attain that particular CO. So this is how we have to well definedly we have to write there is action taken based on the result of evaluation of CO, PO and PSOs. And then action implemented, there is curriculum intervention, pedagogical initiative, support system improvement, technological integration. This is how we have to write there is action implemented. Based on this implementation, evidence of implement CO attainment calculation sheet, gap analysis document, action plan and action taken report, tutorial and remedial class attendance record, revised lesson plan and teaching methods, case study, worksheet, samples and question bank, CAD or CAE activities record, before and after performance comparison. So we have to close the loop with the help of the outcome, that is continuous improvement, CO attainment in the subsequent years. We have to show the progress. So this is one of the another case example for there is action taken based on the result of evaluation of CO attainment, that is 8.1.1, and then 8.1.2, that is action taken based on the result of evaluation of POs and PSOs attainment. So here for the CO target, if it is not yet attained, then we have to identify the gap. In order, based on the identification of the gap, we have to what kind of action taken that can be carried out, and that we have to implement to improve that particular COs. So then we have to conduct the reassessment and improvement to based on the gap identified in the earlier cases. So similarly, it was improved. Likewise, we have to show the evidence. Similarly, for PO and PSOs also, we have fixed the batch target. So if it is not yet attained, then we have to identify the gap, how much the gap percentage is there. Based on the gap identification, we have to take action taken that is in the program level, POs and PSO target. So some of the evidence we have to keep it in the file. So next one, that is 8.2, academic audit and action taken thereof during the period of assessment carries 15 mark. Evaluation guidelines, availability of external academic audit process 2 mark, plan of action to address the recommendation 3 mark, record of action and corrective measures taken during the assessment period carries 10 mark. So some of the document evidence of the academic audit, assessment criteria, frequency, conduct mechanism, action plan based on the audit, implementation. Next one, 8.3, improvement in faculty qualification and contribution carries 15 mark. As per the NBA guidelines, evaluation assessment is based on the improvement with CAY M3 considered as the base year in the following areas. A. Improvement in the number of faculty with PhD carries 6 marks. The average number of the faculty member with PhD degree over the past 3 years is more than 60% compared to the required number of faculty members with PhD. If it is there, then 6 mark. The average number of the faculty with PhD degree over the past 3 years is more than the 40% compared to the required number of faculty with PhD. It carries 4 mark. The average number of the faculty with PhD degree over the past 3 years is more than 20% compared to the required number of faculty members with PhD carries 2 mark. Improvement in the number of publication in the pre-reviewed journals carries 6 mark. Improvement in the number of publication in conference carries 3 mark. So next, that is as per the table number 8.3.1, improvement in qualification and publication, there is number of faculty members with PhD degree, number of publications in pre-reviewed journals, number of publications in conference. There is CAY M1, CAY M2, CAY M3. We have to provide the quantitative data. 8.4, improvement in the academic performance. As per the evaluation guideline. Assessment is based on the improvement of academic performance with CAY M3 considered as the base year in the following areas. Academic Performance Index, that is API for first year student in the program, that is 3 mark. Academic Performance Index API second year students in program, 3 mark. Academic Performance Index of third year student in the program carries 4 mark. So some of the document evidence for the improvement in the classrooms, academic as well as research facilities, simulation tools, usage of digital tools, interactive whiteboards, and other device aims to enhance learning experience. The summary of criteria 7 and 8. So the criteria 7, facilities and technical support, that is adequate classroom, laboratory, workshop, computer facilities, technical manpowers are provided, maintained and effectively utilized to meet curriculum and learning requirements. Another one aspect, continuous enhancement, new or additional facilities, modernization, advanced equipment, center of excellence, safety proficiency, and laboratory upgradation are introduced based on the academic, project, research, and industry requirements, support by documentary evidence. Criteria 8, continuous improvement, COs, POs, and PSOs attainment result are systematically analyzed to identify the gap, followed by curriculum intervention, improved pedagogy, remedial support, technology integration, and corrective action. Another one aspect in the criteria 8, there is evidence of improvement, academic audit, faculty qualification, publication improvement, academic performance analysis, action taken, report. Demonstrate the cycle of gap identification, action plan, implementation, effectiveness, verification, continuous improvement. Thank you for your patient listening.